So earthquakes are another interesting part of plate tectonics in addition to volcanoes and mountain building and different things like that. So let's dig into it a little bit. Earthquakes occur from all different plate boundaries. They can occur when the plates converge together, when they dive apart, or from transform boundaries where they kind of slide against each other. And eventually, there's a piece of land or rock or mantle that might slip underneath the earth. And when that piece slips, it will cause an earthquake or a shaking of the earth. And that those ripples, that shaking, will move all the way up into the epicenter, which is the part of the land that feels the earthquake. So there can be earthquakes underground that we don't even feel because they don't reach up into the crust or the lithosphere or the hydrosphere. So these can be visible, the really big ones can be, and here's a good example of a fault slip. So you can see where the two plate boundaries meet and where one of them slipped underneath the other one. This map should look really familiar to you. These are our plate boundaries, and you should have seen this if you watched the volcano. This is the Ring of Fire, which is where most of the seismic activity occurs, or where the most plate converting and diverging and all that stuff occurs. It can be very deadly. There's a lot of activity in this area, and that's very important to know. The United States would be right around here. So this is where we are. There is some seismic activity over there, but not as much as Asia. All right, so underneath the ground, we start off with our primary wave, which is in the liquid and the solid layer. And these cause the rocks and the liquid layer to move back and forth really, really quickly. After that shock or that wave, there is a secondary wave, or known as the S wave. And this one goes a little bit slower, about half as slow. And this is only in the solid layer. So if you look, this is the P wave. The S wave only occurs in the solid layer. Then we hit the surface waves, which is when they hit the crust. And these are the ones that are deadly. They are very slow and they ripple, kind of like water, and they cause a lot of damage. Scientists measure earthquakes by the Richter scale to kind of see how bad is it really, and it can go all the way up to 10. The worst known one is a 9.5, but that doesn't mean that a 10 hasn't occurred back in the prehistoric times. When we have a 1 or a 2, you usually don't feel it, and it's probably underneath the crust. But eventually, the 6s, 7s, 8, those hit the crust and they cause a lot of damage. The worst one that has ever happened was in 1960, which was a 9.5 on the Richter scale. This was in Valdivia, Chile, and it caused a lot of deaths. Earthquakes, along with other factors like volcanoes, meteors, and erosion, can cause tsunamis. So basically, an earthquake occurs underneath the ocean or in the lithosphere, right underneath that hydrosphere, and it causes a huge wave. And that wave gets larger and larger as it gets closer to the shore. And once it gets onto the shore or onto that lithosphere, it causes a huge wave that can devastate any communities in that area. The areas in red are where tsunamis are most high risk. Yellow are very low risk, and gray, usually it's very, very unlikely for an earthquake to occur. So here in North Dakota, we don't see tsunami activities. But that doesn't mean it's not possible. If we had a very, very, very deadly tsunami, we could have those issues. Over here in the Pacific Ocean, if you remember, our Ring of Fire, these areas are often devastated by terrible tsunamis. So this red area is has a lot of seismic activity with that. But luckily, people have started to create different ways to protect the community from earthquakes and tsunamis. So this would be an earthquake kit that a lot of people who live near the plate boundaries would have in their homes. So a lot of important necessities. And engineers have also created buildings that are less prone to be destructed by earthquakes. Same with tsunamis. There are some tsunami practices to get high on the ground, stay there, and wait for the tsunami waves to move. And some innovators are trying to create buildings that can survive the large waves of tsunamis.